As someone who has played ice hockey almost their entire life, some of my fondest memories revolve around ice. I'm also very privileged to be part of an amazing charity, Inclusive Skating, who aim to support people with disabilities to participate in ice sports. Not only does ice allow for people to be involved in various sports, in many ways life on Earth as we know it depends on ice. It provides most of the world's fresh water supply, keeps global sea levels from rising disastrously, and it provides vital data about the past and future of our planet. However, ice is also common in our solar system. From ice packed into comets to polar ice on Mars to Europa and Enceladus, icy moons of Jupiter and Saturn respectively, water ice is a crucial ingredient in the search for life in space. So with that in mind, here are 10 things you should know about ice. 1. Ice on Earth is called the cryosphere. When scientists talk about the cryosphere, they are referring to ice on Earth, which includes all types of frozen water as well as permafrost, which is soil that has remained below freezing for at least 2 years. The oldest permafrost has been consistently frozen for around 700,000 years. The word cryosphere comes from the Greek words cryos meaning cold and sphera meaning a globe or ball, and cryospheric sciences is the term for the study of the cryosphere. There are many different areas of scientific research involved in studying the cryosphere, such as geology, hydrology, meteorology and climatology. Although cryosphere is the overall term for ice on Earth, there are a lot of different names for types of ice, including separate vocabularies for describing Arctic and Antarctic sea ice. Brash, frazzle, nihilus and pancake ice are a few of the types of sea ice found in both. If you're trying to navigate through waters in the polar regions, it's important to know the difference between an iceberg and an icefoot, a bummock and a hummock, and a floe and a flowberg. If you think that would be tough to remember, the Inupiaq people of Alaska have 100 names for ice based on their knowledge of characteristics and behaviour of frozen water. 2. There have been many ice ages on Earth. And no, I'm not talking about the successful movie franchise. Sometimes you might hear people referring to the Ice Age. However, there have actually been many ice ages in Earth's history, mostly before the emergence of humans. Some of these have been quite mild by comparison, meanwhile others have frozen the entire Earth for tens or even hundreds of millions of years. The first of these ice ages was around 2 billion years ago. Earth continually cycles through periods of warming and cooling. However, the Earth is currently warming up 20 times faster than any recorded previous point, and research is being conducted into the effect human activity is having on the Earth. One way that climatologists can anticipate future climatic conditions is by exploring the content of ice cores, cylindrical samples of ice from glaciers, by analysing the dust, minerals, ash, gas bubbles and human-made pollutants contained within the ice which have collected there for millennia. Scientists can also learn about forest fires, volcanic activity, the extent of sea ice, solar variability and atmospheric circulation. 3. Ice harvesting used to be a key industry. It may seem strange given our modern society to think that at one time ice harvesting was once a key industry in advancing mass production of meat and other easily spoiled items, but in the 1800s this was the case. For thousands of years, lots of different methods of preserving food so it would last longer were tried, such as canning, salting and drying. However, the best method that was discovered was to keep food cold using blocks of ice. Ice harvesters would pull blocks of ice from frozen lakes, which could then be sold and used in household ice boxes. Due to pollution, many natural sources of ice were contaminated, so an alternative method of keeping food cold was required. This led to many innovations that ultimately resulted in the modern electric refrigerator. The first electric refrigerator to have a widespread commercial success was produced in 1927 by General Electric. Today there are many different brands and types of refrigerators, from households to restaurants and even in hospitals for storing medicines and vaccines. 4. Ice storms can be unpredictable and deadly. For an ice storm to occur, snow forms in cold air high up and starts to fall to the ground. As it falls, it passes through an area of warm air, melting the snow into drops of rain before passing through a thin cold layer. The raindrops don't have time to refreeze until they come in contact with a cold surface, where they then immediately turn to ice. This results in a thick glaze of ice that results in hazardous driving and walking conditions, snapped power cables, burst water pipes and broken tree branches. In fact, the weight of the ice can be so great that entire trees and even steel-framed electricity pylons can be brought down. The effects of ice storms can lead directly and indirectly to numerous illnesses and deaths. Obvious causes directly resulting from ice storms would be vehicle crashes due to frozen roads and people being hit by falling branches, for example. Indirect illnesses and death can be caused by things such as carbon monoxide poisoning when people need to use alternative heating and cooking methods indoors due to power cuts, and conditions such as hypothermia as a result of damaged heating systems during an ice storm. Scientists are exploring how and where ice storms are likely to strike in future by studying weather patterns and simulating ice storms. 5. Ice doesn't only exist on Earth. As I said at the start of this video, ice can be found elsewhere in our solar system. Hydrogen and oxygen, which are the two elements that make up water, are abundant in our solar system. However, the amount of water different planets in our solar system have depends on how close to the Sun they are. Those furthest from the Sun, such as Jupiter and Saturn, have much more water than Earth, Mercury and Mars, which are all much closer to the Sun. This is because the high temperatures these planets experience make it harder for water molecules to form. Earth sits in the Goldilocks zone, where it is neither too hot nor too cold for liquid water to exist. Since liquid water is essential for life, or at least on Earth, scientists involved in the search for life in space look for possible sources of liquid water. Jupiter and Saturn have several icy moons, and one of the most interesting of these is Jupiter's moon Europa, which is covered by a layer of ice about 10 to 15 miles thick. It is believed that the cracks and ridges which have been seen on its surface are the result of an ocean of liquid water contained below that frozen surface, leading many to speculate whether Europa is capable of sustaining life. 6. There's such a thing as an ice volcano. The technical name for these is cryovolcano, and it is a type of volcano that erupts liquid water, ammonia and hydrocarbons, known as cryolava, from a supply of cryomagma below the surface. Like a typical volcano, eruptions can take many forms, such as through cracks and cryolava flows, and the amount of cryolava produced varies greatly. Unlike typical volcanoes, cryolava quickly freezes immediately after an eruption. Although rare within the inner solar system, cryovolcanoes have been observed further out. Enceladus, one of the moons of Saturn for example, contains cryovolcanoes at its south pole. When the subsurface reservoir of cryolava is heated and turned into a vapour, it erupts into the chilly atmosphere of Enceladus and freezes to ice particles. As well as Enceladus and the other icy moons in the solar system, it is thought that dwarf planets may also be a source of cryovolcanoes. These eruptions result in important geological features which can be used to study the history of these worlds, though only a small number of cryovolcanic eruptions have been observed within the solar system. 7. Ice on Mars could hold the key to life on the planet. It has long been debated about whether Mars is capable, or was ever capable, of supporting life. Recent satellite images have revealed that Mars stores ice, both dry ice and frozen water, in polar ice caps, permafrost and glaciers. Dry ice is frozen carbon dioxide which freezes at -78°C, and it changes from solid to gas at room temperature without first becoming a liquid. It was long thought that the extremely low temperatures and thin atmosphere of Mars would prevent water from existing in a liquid form, but in 2015 there was compelling evidence reported that briny liquid water is still occasionally present on Mars. Although it is not clear where this liquid water is coming from, it is thought that it could be the result of melting ice below the surface. This then raises the question of whether the planet is currently capable of sustaining life. 8. Icebergs and glaciers don't just come in white. Would you believe that icebergs can come in a range of colours such as blue, green, yellow or even black? White light consists of a rainbow of colours, and each colour has a different wavelength. Glaciers are formed when an accumulation of snow is compressed and frozen. When this happens, more light penetrates the ice rather than being reflected. Longer wavelengths of light like red and yellow get absorbed, while shorter wavelengths like blue and green are reflected. This is why glaciers often appear bluish. Icebergs are formed when sections of glacier break off into the ocean. This is known as calving. However, there are other factors that can affect the colour of an iceberg. Minerals, particularly iron oxides, can run off soil into the water and freeze, resulting in a yellowish colour. Sometimes this will mix with the blue of the iceberg to create a green colour. There are also black icebergs, which can be created in two different ways. One of these is when the ice is very pure and free of air bubbles, resulting in it absorbing enough light to appear black. The other way is the result of volcanic ash being deposited upon an iceberg or glacier. 9. Ice reflects 90% of the sunlight. This is what is known as the albedo effect, which, put simply, is all about how much sunlight is reflected back into space and how much the Earth absorbs as heat. Here's a video of me demonstrating the albedo effect at home by placing one ice cube on a white surface and one on a black surface, both in direct sunlight. Black has a very low albedo, so it absorbs all of the sunlight and its heat. White has a very high albedo, so it reflects the majority of the sunlight and the heat away from it. You can clearly see in this demonstration that the ice cube on the black surface is melting faster due to the albedo of these two different colours. When it comes to the Earth, ice reflects 90% of the sunlight, while the oceans only reflect 10% of it. This means that if the ice disappears, the oceans will heat up much more during the summer. In the winter, ice acts as an insulating layer, trapping heat within the oceans, so they don't lose as much heat as you might think. In the Arctic, for example, where it can reach -30 degrees Celsius and have stormy weather, there would be an incredible loss of heat from the ocean. However, if there is ice covering areas of the ocean, it acts as an insulating layer, allowing less heat to escape and therefore helping to trap heat in the ocean below. 10. The Greenland ice sheet affects Earth's gravity. More than 2/3 of the Earth's fresh water is stored in glaciers, and 10% of the Earth's glacier ice is contained in the Greenland ice sheet. It is the second largest ice mass on Earth after the Antarctic ice sheet. Melting glaciers will affect the global water cycle and have a big impact on water supply and quality, energy generation and increased incidences of extreme weather. The melting of the Greenland ice sheet could raise water levels by 20 feet, however that rise wouldn't be evenly distributed around the world. Oddly, the melting of the Greenland ice sheet will cause more sea level rise in the southern hemisphere. Anything with mass has a pull of gravity, and the Greenland ice sheet is large enough to have enough of a gravitational pull to attract seawater towards the North Atlantic and Greenland. So if that ice disappears, the water will no longer be pulled in that direction. Instead, it will be pulled towards another big gravitational force, which is in Antarctica. However, at its current rate, the Greenland ice sheet will take thousands of years to melt. There are two final thoughts I want to leave you with. 1. From the cubes we put in our drinks to the furthest reaches of our solar system and beyond, ice is an incredible substance, connecting us to other planets, moons, dwarf planets and even comets. It holds potential clues to life on other planetary bodies, while also holding the keys to information about Earth's past and clues to its future. 2. Ice sports can often seem like they are not accessible to people with disabilities. However, inclusive skating's mission is to help all skaters live the dream by providing events, activities, education and training for skaters with additional needs in a caring environment that includes their families. As a charity, inclusive skating rely on charitable donations. To find out more about the charity, learn about their events or find out how to support them, visit inclusiveskating.org. Thank you for watching this Things You Should Know video. The majority of the information for this video came from lists on mental floss and on Science Norway, and supplemented by further research. I've put links in the description to these two main websites, as well as to Inclusive Skating's website. You can subscribe to the channel by pushing the button here, and I've added a link here to my other Things You Should Know videos, and underneath to my STEM activity videos and my STEM career interviews. This has been STEM with Mr. N, exploring 10 things you should know about ice.